In this video, I'm going to provide some more information about the lists data type and get into the first method that we see, which is a built-in function that's designed to work on certain types of data and has a little bit different syntax than the functions we've seen so far. The first thing I'll mention is list membership and the in operator. So this is a token you can type asking whether or not an object is an item in a list. So here the list point line polygon is assigned the variable name features, and the expression here, string point point in features, is a Boolean expression that can reduce to either true or false. And so here this expression, where point is a lowercase p string, is true, but where point is a capital P string, it's false, because as we saw with the ASCII characters, each letter is a totally different code. List slicing, kind of accessing only certain members of a list at a given time, is done with the same notation, same syntax that you would use for a string object. So we saw brackets after the variable name, and that's the same in a string. With a number referring to the index position, and if you had more than one, you would include a colon and the second ending number. And remember that the first index position is inclusive, whereas the second is not. So it goes from index position 1 up to but not including 3. So you're getting B and C, the number 1 index and the number 2 index items. If you just see a colon before a number, that means by default start at the beginning. It's almost like 0:4. If you see list 3 colon, means start at the third and go until the end. So we don't know how many, in this there are 6 positions, so it would be 5. But if you wanted to write that out, it would be len list -1, just because those the index positions begin at 0. So up to and the end. It's understood if you just end on the colon. And if you just enter a colon, it will give you the entire list. So copying a list is a little bit tricky, and I'll discuss why that is. So if you have a list 1, 2, 3, all integers, you assign it to a variable x, and then think you're creating a copy here, y equals x, and then change the 0th indexed element of y to 2. You would expect y to be a 2, 2, 3 integer list, x to remain a 1, 2, 3. But in fact, if you printed out x would also be a list 2, 2, 3 integer, even though you edited the 0th position of y. Now, this is a case of what we call shallow copying or aliasing. So think back to variables referring to objects. So the objects on the computer have a unique identifier, and you can use a built-in function called ID to see what it is in any given session. So that it's kind of a long integer value, it stores the variable information in the computer's memory. So when we copy a list just with a simple assign statement, x equals y, what it's doing is it's creating a new variable but referring to the same object in memory. It's not creating a separate variable, separate in memory with the same value. This can be hard to wrap your head around. The way I like to think of it is, here you and I can both have a banana for a snack or breakfast or something, and we would both call them banana. They would be 2 separate bananas that we could eat. But then you might also We might also just have one banana, you and someone who speaks a different language. You would call it banana. They might call it a platano or a shanjiao or something like that. I don't know a banana in any other languages, but it would be a different word, a different name for the single banana that both of you might want because you're hungry. So this, as I said, is something called shallow copying or aliasing. Sometimes lists can get long, so it's an attempt to just save memory where you can. So here's another example of how when you do a shallow copy of a list, here the variable names are just changed, but B and A, same as Y and X, where they're referring to the same object in memory with different names. And if you ran the ID function on both of those variables, they would have the same number. And if you ran it in an idle session, the number wouldn't be the same. It wouldn't be 43812. That changes. That might be good to check out just to prove that. Okay, A equals 1, 2, 3. 1, 2, 4. B equals A. ID A. ID B. So it's the same number, 875792224. It's a different number than here, but it's the same. It'll change every session that you open it. Now there is a way to make it what's called a deep copy. And that's, as I said, to make a separate object in memory that has the same value, identical value, so to speak. And you use that using slicing with just the colon to create from the start to the end sliced copy. Then C and D will be distinct. If we go back here, B equals A with the square brackets and a colon inside, there's the ID value of A. B is a little bit different. 87, that's the same. But you can see this one ends 936, there ends 224. So now if I change that 0th index position of A to 3, it's not affecting the B list. So if you want a deep copy, a copy that you want to remain separate going forward in your code, you'd use a total slice notation. Here's another just example code of how that is. Here's an example of a list as arguments, so specific values you're passing to a function. 3 functions here, head, tail, delete item. Head takes a list and just returns the 0th index. Tail takes in a list as parameter and refers to the last or rightmost index. And it does so using that len function. So it takes the length of the list and then just subtracts 1 because the index starts from 0 and the length wouldn't be. And then delete item takes 2 parameters. One is list and one is index. There's a conditional. If the index is referring to an index location that's not present in the string, there's a little bit of a warning as to why the function didn't work. Else, del, so delete, the index position of list. So if you had kind of a script like this, numbers are the odd numbers greater than 0, less than 10. You could print the head, that's 1, print the tail, that's 9. And if you call the delete item function, passing numbers, the list, as the argument, and then for the index, you could take the length of numbers divided by 2, so really taking the midpoint index, and the output of that would be 1379. So just getting rid of the 5. And if we added on in kind of 11, 12, I should do 13, then the output of this would get rid of the 7, the midpoint. Because I would have a length of 7 divided by 2, take that out. Here's a function, take in a list and goes through the first and second value in that list, the items, and just adds 100 to them. So it's kind of assume that they'd be numbers. There's a little bit of a string printing out original values in the list, what those values are, incrementing them by 100, and then printing. Matrices. So lists can be nested, as I said. So here, matrix is a 3-item list, and each item is a 3-item list with integers. You can think of this data object as referring to a matrix like that, a 3x3 matrix with the values between 1 and 9. And you can access individual rows, matrix 1, so that's taking just the second row, because the top row would be matrix 0. Matrix 1 is 4, 5, 6. If you're looking for the second from left position of the second from top row, that's a 5. So remember, if you need to refer to index positions of nested lists, you just repeat the kind of bracketed index location. And you can see here the way it's nested, you'd first locate the row and then secondly the column. It's a list of rows. And that's pretty common for a lot of open source Python-based analysis of raster GIS data. And then here we'll get to strings and lists, specifically through one method or a built-in function called split or dot split. Here we have a quote, string, the autumn in New England, assign it a variable name myString, and then, a typo, I've got to make that a capital, or I'll just make this a lowercase. So it's the same here and here. On this variable, we call a method called split. And this is a built-in function that takes as its argument myString, but we write it a bit differently. We don't write it split, open parentheses, myString, close parentheses, like you might expect, like we've seen for functions before. Instead, we put a dot after the variable name, write the function, and then because it's implied that this is the argument, you don't have to put anything in here, but you can. If you don't put anything in, spaces will be taken as the places to split the string. And on either side of a space, the characters will form their own item in that list. So split is a built-in function, only works if you call it on strings, and it outputs a list. So here a 5-item list, 5 strings, each one of them a word. So you can add something, a string, into the parentheses of a split. So you're providing a value for another parameter, and that is the splitting location. So if you put split quote in, that in is not going to be included in the output, and instead the two strings, or the strings are going to be the things that lie to the left of the right of that in. So it would be a kind of awkward looking, the autumn space, New England. The kind of the flip side of that, the way to go from a list to a string, is the dot join method. So my list equals the autumn in New England. No spaces, just strings of those letters, 5 items in that list. So join is something that's called on a string, and that string is essentially what character you want to insert between the items in the list. So if it's an underscore, underscores will be there. If it's a space, all those underscores will be spaces, like so. So that here, the use of the split method is essentially what you need to do in order to answer the first question of Lab 4. Here's an example. It's very kind of similar to that. It's not judges' scores, but it is 5 numbers in a string separated by commas and a space. And so if you want to get the smallest value, the largest value, and the total value, you can first convert that string into a split list of the numbers, and then write a program to figure out which is the smallest, which is the largest, and to sum them all. And if you have a list as an output of the split, the way you might want to run through that using a for loop.